Good evening, students. So we were discussing about haloalkanes and haloarenes, right? So we have started with haloalkanes and haloarenes. So we have seen the introduction part, then we have seen the classification in the previous class. Then we had started with the preparation of haloalkanes. So we have seen the preparations from alcohols, right? So last time we have stopped here, that is from alkenes, right? So we were discussing about the unsymmetrical alkenes. So you know what are symmetrical alkenes? So symmetrical alkenes, so across the double bond, if the number of atoms, carbon atoms are same, right? So they are called as symmetrical alkenes. So whenever you are adding up, suppose you are adding water molecule across this double bond, so how it will add up? So it can add up as CH2H, CH2OH, right? So anywhere, because it is a symmetrical carbon, so so water will split into H plus and OH minus ion. So across the double bond, it can add to any of this carbon. So this is in case of symmetrical alkene. Suppose you have an unsymmetrical alkene. Okay, unsymmetrical alkene means what? Then, so across this double bond, the number of carbon atoms are not same. So here you can see there are so there is one alkyl group and one carbon, and here is only one carbon. So it is called as unsymmetrical alkene. So the number of carbon atom across the double bond is not same. Okay. So whenever you have an unsymmetrical alkene and you want to add alkyl bromide, okay, you want to add alkyl bromide across this double bond. So that time you have to follow a rule called as Markovnikov's rule. So what does Markovnikov's rule states? So Markovnikov's rule states that whenever you have an alkyl halide, the negative part of the alkyl halide will be added to the carbon which will have least number of hydrogen atom. Okay, so the product obtained, you can see here, it is RCH, BrCH3. Okay, so because it follows Markovnikov rule. So whenever you have an alkyl halide and you want to, you have an unsymmetrical alkene, so the addition takes place according to Markovnikov rule. It will follow what? It will follow the Markovnikov rule. Okay, now suppose, now there is something called as anti-Markovnikov rule. Okay, so what do we mean by anti-Markovnikov rule? So this reaction, it proceeds in the presence of peroxides. Okay, suppose same unsymmetrical alkene is given, it is added, you are adding what? A hydrogen bromide, okay, or any alkyl bromide, alkyl halide you are adding. The reaction proceeds via peroxide, in the presence of peroxide. So then this follows anti-Markovnikov rule. So anti-Markovnikov rule means what? It is opposite of Markovnikov rule. So what is anti-Markovnikov rule? Anti-Markovnikov rule states that the negative part of the alkyl halide is added to the carbon which is having more number of hydrogen atoms. So this is a unsymmetrical alkene. So where the negative part will be added? Negative part will be added to the carbon which is having more number of hydrogen atoms. So this is the product which is obtained. So it will be RCH2CH2Br. Right. So this is anti-Markovnikov rule. Suppose they give you a reaction. Suppose this is CH3, CH double bond CH2 plus HBr in the presence of peroxide. So if on the arrow peroxide is given, okay, you have to understand that this reaction is, if there is alkene and you're adding alkyl bromide, that is alkyl halide, and the reaction is proceeding via in the presence of peroxide, that means this reaction is anti-Markovnikov rule. Okay, and suppose there is nothing written on the aroma. There is a unsymmetrical alkene. Okay, there is an unsymmetrical alkene and there is alkyl halide. Then the addition takes place according to Markovnikov rule. Okay, so these are the rules which you have to keep in mind. Understood? So this is the second preparation which we have seen. Next is halide exchange method. So halide exchange method means what? Here from chloroalkanes or bromoalkanes. So the starting product which we are going to take is chloroalkanes or bromoalkanes. Okay. So chloroalkanes or bromoalkanes, when you react it with sodium iodide, okay, when you react it with sodium iodide in the presence of acetone, dry acetone, okay. So dry acetone, you will yield what? You will yield iodoalkanes. So these iodoalkanes, so Finkelstein reaction, it is a reaction where you can prepare iodoalkanes. Okay, iodoalkanes are prepared from this reaction. And the side product is NaCl. Okay, so this is Finkelstein reaction. Then what is next is Scott's reaction. So from Scott's reaction, you can prepare alkyl fluorides. Okay, you can prepare your alkyl fluorides. So how you prepare this? So your what is taken? Alkyl chloride is taken, that is methyl chloride. So 2 molecules of alkyl methyl chloride is reacted with metallic fluoride. Okay, so you're going to react it with metallic fluoride, such as other metallic fluoride can be AgF, then Hg2F2, then CO, cobalt fluoride, okay, or tin fluoride. So these are some of the metallic fluorides. So when alkyl chloride, so you can take any alkyl chloride or any alkyl bromide, and you have to react it with some metallic fluoride. Okay, then you get fluorides. Okay, you get what? You yield their alkyl fluorides. Okay, alkyl fluorides are obtained, and these alkyl fluorides which are obtained, so this is the Scott's reaction. So Finkelstein reaction, you can prepare what? Iodoalkanes. So iodoalkanes are prepared from chloroalkanes or bromoalkanes. And Scott's reaction is what? In Scott's reaction, you can prepare alkyl fluorides. So alkyl fluorides can be prepared from chloro okay, alkyl fluorides or alkyl bromides. So these are the two important name reactions wherein the halogens are exchanged, right? You can see that there is an exchange in halogens. So this MCQs we have already seen. This is the first part, what we have discussed, the classification part. So we'll solve some questions, okay, based on the preparations, what we have discussed in the last class. So from amongst the following alcohols, the one that would react fastest with concentrated HCl and anhydrous ZnCl2 is A, 2-methylpropanol, B, 1-butanol, C, 2-butanol, D, 2-methylpropane-2-ol. Yes. Which is the alcohol which could react with concentrated HCl? What is concentrated HCl and anhydrous ZnCl2? Swati has replied it as C. What about others? Okay, Sanjay has replied it as B. Any other answers? You have to tell what is concentrated HCl and anhydrous ZnCl2. Concentrated HCl and anhydrous ZnCl2. Yes, it is a Lucas reagent. Okay, it is Lucas reagent. So we have seen in the last class about preparation of alkyl halides from alcohols, right? So whenever you are seeing the alcohols, what you have to see, the reactivity of alcohols, we have seen that tertiary is more stable, then secondary, and then primary, right? Tertiary is more stable than secondary and then primary, right? So which among the following will, so you have to see which among the following is first. So first preference should be given for tertiary alcohol, then for secondary, and then for primary. So just see which is tertiary among the following. Archana has replied it as D. Okay. Now I'll write the structures. Okay. So this is 2-butanol. Okay. Then I'll draw the structure of others also, and you have to tell which among the following will be the correct one. Okay. Then I'll write your structure 1. Yes. Can you tell me? Okay, Swati has replied it as D. Yes. So the answer is D. So this is primary, this is secondary. Okay. So this is again further divided to 2. This is primary. This is tertiary. Right. So D is the correct answer, right? D is the correct answer. Yes, D is the correct answer. Okay, so whenever you are taking alcohols, okay, whenever you are reacting alcohols with Lucas reagent, so remember what is Lucas reagent? Lucas reagent, it is concentrated HCl and anhydrous ZnCl2. So whenever you are reacting alcohols, whenever alcohols is taken, so the reactivity order will be tertiary, will be more stable than secondary and then primary. So this is the reactivity order. So you have to see, first write the structure and then you will come to know which is tertiary, which is secondary. Okay, then you can analyze the things. So next question, the name of the product obtained by the addition of HI to propene in the presence of peroxide catalyst is? Yes, I'll write the structure of propene, CH3, CH double bond CH2 plus HI. What is HI? Hydrogen iodide, which is a alkyl halide, and this is an unsymmetrical alkene. And on the arrow mark, what is written? Peroxide. Yes. So what rule it will follow and what will be the answer? Yes, what will be the answer? Yes. Okay. Archana has replied it as D. Aishwarya has replied it as B. Others? So I've just discussed it. So at the starting of the class only, I've discussed it about the peroxide, right? What is Markovnikov rule? What is anti-Markovnikov rule? So whenever a reaction is written and the aroma peroxide is written, peroxide means it will go via the anti-Markovnikov rule. It will follow anti-Markovnikov rule. Okay. So it will so what will be the product? So what is anti-Markovnikov rule? The negative part of the alkyl halide will be added to the carbon, which will have across the double bond of the carbon, which will have more number of hydrogen atoms. So where it will add? So the answer will be CH3, CH2, CH2, Br. Okay, so the answer is D. Yes. Archana and Shreya Kumari has answered it right. It is D. Okay, the answer is D. I hope you are clear. So whenever, if it is said that if the question was name the product obtained by addition of HI to propene, okay, then it would be what? What would be the answer? Without catalyst, CH2 plus HI, okay. Then the answer would be CH3, CHI and CH3, okay. So that is 2-iodopropane. So the answer would be 2-iodopropane. So not propene. Okay, this is not propane. It is 2-iodopropane. Option B. Okay, it is 2-iodopropane. So option B is the right answer. Okay, 2-iodopropane, not propene. It is not double bond. It will be single bond only, because across you are going to remove this double bond, and there you are going to add it. So it will be, how it will be 2? This is 1, right? So 1, 2, 3. It is 1-iodopropane. Sorry. Okay. So numbering, you have to see it is 1-iodopropane. So option A is the correct answer. 1-iodopropane. Okay. So this is 1-iodopropane. If it would be without the presence of peroxide, if it would be without the peroxide, then it would be 2-iodopropane. The answer would be 2-iodopropane. So correct answer is 1-iodopropane. That is A option. So in the presence of peroxide. So anti-Markovnikov rule is what? So anti-Markovnikov rule. So if this is a unsymmetrical alkene and this is alkyl halide. Okay. So if peroxide is written, okay, if peroxide is written, peroxide like H2O2, then Na2O2, okay, sodium peroxide, hydrogen peroxide. So these are the peroxides. Benzoyl peroxide. So these are the peroxides which you are going to use. So if peroxide is written, then what will have? The negative part will be added to the carbon across the double bond, which will have more number of hydrogen atoms. So this will be CH3. Then this hydrogen will be added to this carbon. So it will be CH2 and I. So when you are naming it, this will be 1, 2, and 3. So it will be 1-iodopropane. So option A is the right answer. Okay, sorry. So it will be 1-iodopropane. So we'll go for the next one. I hope it is clear. Okay. So we'll go for the next one. The best method for the conversion of an alcohol into alkyl chloride is by treating the alcohol with A, phosphorus trichloride, B, phosphorus pentachloride, C, thionyl chloride in the presence of pyridine, and D, dry HCl in the presence of anhydrous ZnCl2. Yes, good. Okay, so the answer, yes, Nandita, Archana, Aishwarya have answered it right. It is C. Okay, so we have seen this. Whenever you want to convert an alcohol into an alkyl chloride, okay, alcohol is converted into alkyl chloride. So we can use thionyl chloride in the presence of pyridine. So thionyl chloride in the presence of pyridine is a base. So what it will do, what it will yield? It will yield SO2 gas plus HCl. Okay, so these are the side products. So these side products, they are gaseous in state. So this will escape out. And the product obtained will be, you can easily separate it out. Okay. So option C is the right answer. So it is thionyl chloride in the presence of pyridine. So whenever you are doing conversion of an alcohol into alkyl chloride, you have to treat the alcohol with thionyl chloride in the presence of pyridine. Why we are preferring this? Because the byproducts which are obtained, they are gaseous. That is sulfur dioxide and hydrochloric acid. So both are gaseous. Next, ethyl bromide is industrially prepared from A, ethene plus HBr, B, ethanol plus Br2 bromine, C, alcohol plus hydrogen bromide, D, none of this. Yes. So ethyl bromide, how it is prepared? Okay, Archana has replied it as B. What about others? Swati has also replied it as B. So industrially, okay, industrially in industry, how ethyl bromide is prepared? What is ethyl bromide? It is C2H5Br. Okay. Shreya Kumari has also answered it as B. So ethyl bromide is C2H5Br. So if I take alcohol like ethyl alcohol C2H5OH, and if I treat it with HBr, okay. So alcohol, if I treat it with HBr, and if I add some concentrated H2SO4, that is sulfuric acid, I'll obtain C2H5Br, that is ethyl bromide plus water. So option C is the right one. Okay, so ethyl bromide can be industrially prepared from alcohol and hydrogen bromide. So ethyl bromide is industrially prepared by refluxing. So you can reflux this alcohol with hydrogen bromide in the presence of little amount of concentrated sulfuric acid. Okay. So the product obtained will be ethyl bromide and water. So you can see this, right? So this is the reaction. I hope you have got it. So it is obtained from alcohol and HBr. I have written the reaction. Alcohol, ethyl alcohol is treated with hydrogen bromide. Okay, in the presence of concentrated H2SO4, right? H2SO4. So you get ethyl bromide and water. So this is the reaction. So C is the answer. Next. Ethyl chloride on reduction with lithium aluminum hydride gives compound X as important product. X on chlorination with 1 mole of chlorine in the presence of light at ordinary temperature gives Y, and what is Y? Okay, so you have to follow this set of rules. So for first is what? Ethyl chloride. So C2H5Cl. Okay, so ethyl chloride on reduction with. So reduction means what? Addition of hydrogen. So I'll add hydrogen, and this with lithium aluminum hydride. So lithium aluminum hydride, it is a good reducing agent. Okay, it is a good reducing agent. So if you treat ethyl chloride, that is in the presence of lithium aluminum hydride, so what it will do, it will add a hydrogen to give you a compound X. So what is a compound X? So if I am adding hydrogen, so this will be C2H6. Okay, the compound X will be C2H6. Now this C2H6 compound, further what we are doing? We are doing chlorination with 1 mole of Cl2. So I'll do chlorination. So I'll do chlorination with Cl2. So what I'll obtain? I'll get C2H5Cl. Okay, I'll get C2H5Cl. So in the presence of light, that is chlorination in the presence of light, to give you the compound Y. So this is Y compound, this is X compound. So what is our Y? Our Y is C. Okay, our Y is ethyl chloride itself. So ethyl chloride, what we have done, we have treated it with lithium aluminum hydride. So lithium aluminum hydride, it is a good reducing agent. So what it is doing, it is adding up of hydrogen to give you the compound X. So the compound X here is C2H6. So this on further chlorination with 1 mole of chlorine in the presence of light at ordinary temperature will give you Y. The Y is ethyl chloride again. Okay. Okay, so our option C is the right answer. So we'll go for the next question. What is A in the following reaction? So you have to, so they have given a reaction and you have to tell what is A. Can you tell? So this is a unsymmetrical alkene. Yes, across this double bond, the number of carbon atoms is not same. So it is unsymmetrical alkene, and this is a alkyl halide. Is there anything written on the aroma? No. So this is a so you can follow Markovnikov rule. Okay, you can apply your Markovnikov rule and you can tell me the what is A. Okay, you can tell me what is A here. Okay, Archana has replied it as B. What about others? Okay, Ishwar has replied it as C. Swati B. Sanjay has replied it as B. Okay, so what is Markovnikov rule? The negative part of the alkyl halide will be added across a double bond to the carbon, which is having least number of hydrogen atoms. Right. So what will be the product? So the remaining things will remain as it is. Okay. So CH2, only the change will be at this carbon. So CH, Cl, and CH3. Right. So which is the correct answer? It will be C. Okay, it is C. Understood? So who has answered it as C? Nandita, Kirti Gowda, Okay, Aishwarya. So the answer is right. So C is the correct answer. Understood? So this is Markovnikov rule. So Markovnikov rule states what? Whenever you have unsymmetrical alkene, the alkyl halide, okay, the negative part of the alkyl halide will be added to the carbon which is having least number of hydrogen atom. This is Markovnikov rule. So, option C is the right answer. So don't see if the molecule is too big also. Don't look at the molecule. Only you have to concentrate on this particular double bond, across the double bond only. Okay, so negative part will be added to the carbon with the least number of hydrogen atom, and the other hydrogen will be added here. So it becomes CH, Cl and CH3. Understood? Yes. So this is the way you're going to solve it. So next we are going to see is nucleophilic substitution reaction. So what are nucleophilic substitution reaction? So if you have a alkyl halide, okay, if you have a alkyl halide and if you react it with NaOH or KOH, okay, if the reagent used is sodium hydroxide or potassium hydroxide, the substituted product form is alcohol. So the class of product which is obtained will be alcohol. So if you treat alkyl halides, okay, if you treat alkyl halides with the NaOH or KOH, you obtain alcohols. Okay, so what are these nucleophilic substitution reactions? First, we'll see that. What are nucleophilic substitution reactions? So in alkyl halide, we have seen that the CX bond is polar bond, right? In the first class itself, we have seen that the CX bond is a polar bond. Why it is polar bond? Due to minus I effect. Okay, due to minus I effect of the halogen atom which is attached, the positively charged carbon is easily attacked by the nucleophile. This positively charged carbon can be easily attacked by the nucleophile and it will substitute this halide atom. Okay, that is the halogen atom. These reactions, those are called as nucleophilic substitution reaction. So how the nucleophilic substitution reaction will carry out? Nucleophile is there, okay, and this is the alkyl halide. So this is positively charged, this is negatively charged, and what type of reaction will take place? This is the nucleophilic substitution reaction. So the nucleophile will leave with its pair of electron, and this nucleophile will attack this positively charged carbon. Okay, so this is nucleophilic substitution reaction. So first, if the reagent taken is NaOH or KOH, that is sodium hydroxide or potassium hydroxide, you obtain the class of product called as alcohols. Second, if you react alkyl halide with sodium alkoxide, okay, if you react it with sodium alkoxide, what you will get? You will get ether, okay, that is ROR dash. Okay, so it is ROR dash. So the answer will be ROR dash, that is ether. ROR dash is ether. So this reaction is called as Williamson ether synthesis. This name reaction is called as what? It is Williamson ether synthesis. Okay, then the next is if you react the alkyl halide with KCN, that is alcoholic KOH, then what you obtained is RCN, that is alkyl cyanide. You obtain what? Alkyl cyanide. So this nucleophile, okay, so you obtain what? Alkyl cyanide or nitriles. It is also called as what? It is also called as nitriles. Okay, so haloalkanes, it reacts with KCN to form alkyl cyanides as the main products. And if you react it with AgCN, okay, if you react it with AgCN, that is a silver cyanide, okay, then you will form what? Isocyanates. You will obtain isocyanates as the main product. Okay, so this is the difference. So if you react it with potassium cyanide, you will get cyanide as a product. If you react it with silver cyanide, then you will get what? Alkyl isocyanate. Isocyanate means what? Your nitrogen will be attached to alkyl group and your carbon will be attached to the alkyl group. Okay. Then next is if you react it with AgNO2. Okay, if you react it with AgNO2, you get nitroalkanes. Okay, nitroalkanes are obtained. And if you react it with And if you react it with potassium nitrate, you obtain alkyl nitrite. Okay, you obtain alkyl nitrite. So you will obtain alkyl nitrites as the product. So these are the various reagents from which you can get various products. Okay. So these are nucleophilic substitution reactions. So there are some more reagents. So if you react it with RCOAG, okay, then you will obtain esters. Esters. Then if you react alkyl halides with lithium aluminum hydride is a reducing agent. So you will obtain alkanes. If you react it with lithium, okay, R lithium, then so it is a metal, right? So you will obtain alkanes. Then if you react it with ammonia, you will obtain primary amine. So one of the hydrogen is replaced by alkyl group. Then if you react further again with excess of ammonia, you will obtain secondary amine, wherein again the second hydrogen is replaced by the alkyl group. Again, further, if you treat it with again alcoholic ammonia, the hydrogen, the last hydrogen will be replaced by the alkyl group. And lastly, if you react excess with ammonia, it will form quaternary ammonium salt. Okay, so all the hydrogens are replaced by alkyl group. So this is the reaction, nucleophilic substitution reaction. So based on this, we'll solve some MCQs. So which of the following alkyl halide is used as a methylating agent? So which of the following alkyl halide is used as methylating agent? Ethyl bromide, benzyl chloride, methyl iodide, or ethyl chloride. So which is used as a methylating agent? The answer is C. Okay. Methylating agent is used as uh, methyl iodide. So alkyl halide which is used, following alkyl halide which is used as methylating agent is CH3I. Okay. So this is the answer. So we'll go for the next question. Ethyl chloride on heating with AgCN forms a compound X. The functional isomer of X is. Okay. So the reaction I will write here. So what they have given, ethyl chloride. So C2H5Cl. If you react it with AgCN, okay, alcoholic AgCN, then what product you will obtain? Okay, Archana has replied it as C. What about others? I have given this. If AgCN is reacted, what product is obtained? And when KCN is reacted, what product is obtained? Don't make hurry in answering. Just think on the answer. Okay. Just see here. Just see with AgCN and KCN, what products are obtained. Yes, so with AgCN, what product is obtained? Isocyanides are obtained. So it is option A. Okay, option A is the right answer. So functional isomer is ethyl isocyanide. Okay, so option A is the right answer. So we'll go for the next. What are the reagents and reaction condition used for converting ethyl chloride to ethyl nitrite as a major product? So what conditions can be used for converting ethyl chloride to ethyl nitrite? So what are the conditions can be used? Sanjay has replied it as C. From chloride to nitrite. Endo. So the reaction condition used is A. Okay, potassium nitrate. Here you can see. Wait, I'll show you. Yes, here you can see at the last alcoholic NO2, KNO2, alcoholic KNO2, right? From alkyl halide, it is converted to nitrate. So, which is the correct answer? Yes, in among the following options, where is KNO2 is there? In A option, right? So, from ethyl chloride, when you are converting to ethyl nitrite, okay, you are using this conditions. So these conditions, reaction conditions are used. So potassium nitrate, it converts ethyl chloride into ethyl nitrate. Okay, it is converting into ethyl nitrate. So these are the reaction conditions. So option A is the right answer. Okay, you have to understand the reagent charts. If you don't understand that, then it will be very difficult. So next we are going to discuss about elimination reactions. So what are elimination reactions? Alkyl halides undergo beta elimination reaction in the presence of alcoholic KOH to yield alkenes. Okay. So what is beta elimination? So from the beta carbon, the hydrogen is eliminated. So alkyl halide, it undergoes beta elimination in the presence of alcoholic KOH. So alcoholic KOH, that is potassium hydroxide. So you can see this is, so from this halide, this is the alpha carbon, this is beta carbon, and this is gamma carbon. So from this, your what is gone? Your hydrogen is gone, one of the hydrogen. So your bromo, so your one bromo ethane, it is reacted. So alkyl halide, this is alkyl halide, it is treated with what? It is treated with alcoholic KOH. Then from the beta carbon, see here, CH2, Br, CH2, and CH3. So this is alpha, this is beta, this is gamma. This is treated with what? Alcoholic KOH. What you will obtain? So this will be CH2, Br, this will be CHH, this will be CH3. Okay. So what is happening? This will go and this will go. And what is the product obtained? It will be CH2 double bond CH, CH3. Understood? So propane is obtained. So this is the beta elimination. So from the beta carbon, beta hydrogen is gone. Okay, so from the beta carbon, hydrogen is gone. So this is called as elimination reaction. So whenever you have an unsymmetrical alkene, now you know what is unsymmetrical alkene. So whenever you have unsymmetrical alkene, alkyl halides, okay, whenever you have unsymmetrical alkyl halides, elimination will follow Sedgwick rule. So there is something called as Sedgwick rule. So according to which hydrogen is eliminated preferentially from the carbon atom which has less number of hydrogen atoms. So another rule which is very important. So whenever you have elimination reaction, so that time you are going to use what type of rule? It is Sedgwick rule. So the hydrogen will be eliminated preferably from the carbon atom which has less number of hydrogen atoms, and thus highly substituted alkene will be formed. Okay, so the carbon atom hydrogen will be eliminated from the carbon which has less number of hydrogen atoms, and highly substituted alkene is formed as a major product. So this is a Sedgwick rule. So whenever you have an unsymmetrical alkene, you have to apply what? You have to apply Sedgwick rule. So this is the Sedgwick rule. So you can see 2-bromobutane is given. So what they have told. So now here you can see there are two, preferably two this. So this is this will be alpha, right? This is alpha carbon. This is also beta. This is also beta. So what did they say? That whenever you have more than one unsymmetrical alkene, okay, whenever you have unsymmetrical alkene, that time the hydrogen will be removed from the carbon which is having least number of hydrogen atom, and highly substituted product will be formed. So among this CH2 and CH3, which is having less number of hydrogen atom, this carbon, right, this beta carbon will have, so it will form this product. So what will be the product from CH3, CH double bond CH, CH3. So this is the major product. Okay, this is a major product, and this is the minor product. Minor product means less, the amount of yield will be less, and here the amount of yield will be more. So whenever you have beta carbon, that is if you have unsymmetrical alkene and the number of beta carbons are more, that time you have to follow Setzeff rule, and Setzeff rule states that that is whenever you have more than 2 beta carbons, so that time the hydrogen will be removed from the carbon which is having least number of hydrogen atoms. Okay, so hydrogens from the carbon which is having least number of hydrogen atoms. So it will follow Setzeff rule. So the order of reactivity of alkyl halides towards this dehydrohalogenation reaction is tertiary will be more stable than secondary and then primary. So this reaction, beta elimination, it is also called as elimination reaction, also called as beta elimination, also called as dehydrohalogenation reaction. Why it is called as dehydrohalogenation? Because there is removal of one hydrogen and halogen, right? Dehydrohalogenation. One hydrogen and one halogen is removed, so it is called as dehydrohalogenating. Okay, so suppose what is the dehydrohalogenating agent used? If the question is asked, which is the agent which is the agent used as dehydrogenating agent? Okay, which is the agent, dehydrogenating agent? So it is alcoholic KOH. Okay, alcoholic KOH, keep in mind, very important. So alcoholic KOH is called as dehydrohalogenating agent. Okay, so it is used in removal of one mole of hydrogen halide. Okay, so this is beta elimination or elimination reaction. So we'll solve some questions. So elimination of bromine from 2-bromobutane results in the formation of. So these are the 4 options. I want you all to tell me this. So follow the elimination reaction, Setzeff rule, and you can tell me. Yes, elimination of bromine from 2. Okay, should I write the structure? Okay, I'll write the structure. 2-bromobutane. So 2-bromobutane will be CH3, CH2, CH, Br, CH3. So this is 2-bromobutane. Okay. So this will be 1, 2, 3, and 4. Bromobutane, right? So if you want to do a elimination reaction, how? So this is also beta carbon. This is also beta carbon. From where the beta? So according to Setzeff rule, what it is said, it will remove the hydrogen from that carbon which is having least number of hydrogen atoms. So among this, which will have least number of hydrogen atom, this. So the product form will be CH3, CH, double bond, CH, CH3, right? So which is the answer? So this is 1, 2, 3, 4, right? So 2-butene, right? So this will be the major product. So which is the answer? Yes, it is B. Predominantly but 2-ene is formed. Okay, predominantly but 2-ene is formed because it will give you, if you follow the Setzeff rule, it will follow what? So it will follow, if you follow the Setzeff rule, it will give you the major product. Okay, so the answer will be B. I hope it is clear. So you have to apply the Setzeff rule. So we'll go for the next question. N-propyl bromide on treating with alcoholic KOH produces. Yes. What is N-propyl? I'll write the reaction. You can tell me the answer. N-propyl. CH3, CH2, CH2, Br. Okay, so this is N-propyl bromide. So if you react N-propyl bromide, if you react it with alcoholic KOH, so if you react it with alcoholic KOH, it will undergo dehydrohalogenation reaction. So this is alpha, this is beta carbon. Okay, so what type of reaction it will go? Just see what options you have. Yes, there's the answer. Okay, Archana has answered it as B. What about others? dehydrohalogenation reaction. Okay. Ishwarya has answered it as D. Shreya Kumari B. Vinushri as B. Alcoholic KOH dehydrohalogenating agent. Okay. So what it will do? Suppose I'll write the reaction here. Suppose this is CH3, this is CHH, this is CHH and Br. Okay, so this hydrogen and this bromine will go, and it will form what? CH3, CH double bond, CH2. So it is propene. Okay, option D. Option D is the answer, plus KBr plus H2O. So option B is the right answer. Okay, option D. Option D is the right answer. It is propene. So whenever N-propyl bromide, if it is reacted with alcoholic KOH, it is giving you propene. Okay, it is yielding you a alkene. So this is the right answer. So this is a way you're going to solve it. So it will undergo a dehydrohalogenating. Okay, because alcoholic KOH is dehydrohalogenating agent. So one hydrogen and one halide is leaving. So it will be HBr, right? So this it will form propene. So propene is the correct answer. So we'll go for the next one. I hope it is clear. Identify Z in the following series. Okay. So first what they have done, they have taken ethyl iodide, that is C2H5 iodide. It is treated with alcoholic KOH. So if you treat it with alcoholic KOH, what is done here? What is obtained? If you treat it with alcoholic KOH, it will undergo what? CH3, CH2 and I. So it will form what? It will form CH2, CH2, right? It will form CH2, CH2. How it will form CH2, CH2? I'll show you. So I'll write it more simpler. CH, H, H, C, H and I. So what will happen? Suppose so this hydrogen and this will leave and you will get CH2 double bond CH2. Understood? So this is the first step. What I'm getting, this will be first step, that is CH2. Okay, CH2, CH2, alkene. I have obtained alkene. So this is what? X. Okay, this is X. Next is what? Next I'm going to treat it with Br2. Okay, I will go to add Br2. So what I'll do? I'll add Br2. Okay, here and one Br2 here. Okay, one Br here and one Br across this. So this is 1,2 dibromo. Okay, dibromoethane. Then this is further. So this is our Y. This is further treated with KCN. Okay, further treated with KCN. What you will obtain? This Br will be replaced by Cn. So it will be CH2 Cn. So this is what? This is Z. So what is our answer? Which is the answer? Okay, Kirti Gowda has replied it as C. So our answer is what? B. Okay, our answer is B. Okay, so answer is B. I hope you have got the answer. Yes. So you have to follow the set of series and you will get the answer. Okay. One more last question and then we'll stop the session. So a mixture of 1-chlorobutane and 2-chlorobutane when treated with alcoholic KOH gives you what? Okay. So 1-chlorobutane. So if the mixture of 1-chlorobutane, so chlorobutane Cl, CH2, CH2, CH2 and CH3, right? So this is 1-chlorobutane and 2-chlorobutane. So what will be 2-chlorobutane? CH2, CHCl, CH2. So this is CH3, sorry, CH3, CHCl, CH2 and CH3. Okay, so this is 2-chlorobutane. So 2-chlorobutane and this is 1-chlorobutane. So when this is reacted in the presence of alcoholic KOH, Okay, what you will obtain now? What is obtained here? Mixture of this when treated with alcoholic KOH. What is obtained? So this will give you, when this is treated with alcoholic KOH, you will obtain, yes, what are the products which are obtained? A mixture of 1 chlorobutane and 2 chlorobutane when treated with alcoholic KOH. So this will give you CH2, CH, double bond CH, CH2, CH3. Okay, so this is 1 butene. You will obtain 1 butene, and here you will obtain CH2, double bond CH. No, from here Cl will go. So, oh no, this will go from here. Okay, so this will be CH3, CH, double bond, CH, CH3. So this will be 1, 2, 3. So this will be 2 butene. Okay, 2 butene. So mixture of 1 butene and 2 butene is obtained. So option D. Okay, option D will be the right answer. So whenever you are treating a mixture of 1 chlorobutane is taken and treated with alcoholic KOH, you will obtain 1 butene, and with 2 chlorobutane, okay, you are obtaining 2 butene. So it will undergo dehydrohallucination. One hydrogen halide is removed. Okay, so this is a so these were some of the questions based on elimination reactions. So the next part we will so the remaining questions and remaining this we will see in the next class. I hope today's session is clear. Yes. So we will end the session here. Okay, so we'll meet in the next class. Thank you.